So we just covered a lot. Let's review a little bit. We introduced the idea of syntax. Syntax, remember, is just the rules about what kinds of strings of symbols are going to be called correct. They form sentences. And it rules out other strings of symbols. It tells us those aren't proper sentences. So for example, we had the syntax for the negation was that you could put that little symbol, the negation symbol, in front of any sentence and you get a sentence. But you can't put it after the sentence. That would not be a sentence. That would be grammatically incorrect. It would be unsyntactic. It would be gobbledygook. Our semantics, remember, that's about meaning, whereas syntax is about strings of symbols, what kind of strings are allowed, what aren't. Semantics is about what does it mean? Once I've written a sentence, what does it mean? For our atomic sentences, all we care about is are they true or false. So the meaning is simply the fact that that sentence could be true or false. But for the negation, for the conditional, the semantics were more complicated. They were a function of the parts, right? If we knew the meaning of the parts, that is to say the truth value of the parts, then we would be able to tell you the meaning of the conditional sentence or the negation sentence. We introduced the idea of meta-language, the language we use to talk about our language. We use Greek symbols for that, and we need that so that we can say general things about our logical language. And we introduced a conditional and negation, two new kinds of sentences. So now we have three kinds of sentences: atomic sentences, conditional sentences, and negation sentences. Three kinds of sentences. And we've seen the syntax for those, and we've seen the semantics for those. Now, let's remind ourselves in terms of the semantics, we introduced this new tool to express the semantics, and it's a truth table. We're going to use a truth table in three different ways over the course of learning our logical language. But let's just, all we've done now is learn one way to use it, so let's just talk about that one way. It's when we use a truth table to define a connective. We put over here the defined sentence. Right? Sorry. And here we have the sentences that are the parts of the defined sentence. Here we put all possible truth values for these sentences that compose our defined sentence. And then here's our definition. It's the truth values that define the semantics. So look back at our truth table and think about what these four quadrants mean. Here we've listed the atomic sentences in our first case. Then when we switched to our meta-language, we put up here the sentences that form that sentence, right, that we're then defining. The sentence, its definition are the situations, the kinds of ways the world could be in which it's true, the kinds of ways the world could be in which it's false. And over here, we tell you what those kinds of ways the world could be in terms of the possible truth value combinations of the composing sentences, as it were. Okay. That gets a lot easier after you've done it a few times. So it's always the case in logic that practice is what you need to learn it. The historical example I want to share comes from Aristotle, from a book he wrote about the stars. And in this book, Aristotle says, again, our observations of the stars make it evident, not only that the earth is circular, but also that it is a circle of no great size. For quite a small change of position to south or north causes a manifest alteration of the horizon. There is much change, in the stars, which are overhead, and the stars seen are different, as one moves northward or southward. Indeed, there are some stars seen in Egypt and in the neighborhood of Cyprus, which are not seen in the northerly regions, and stars which in the north are never beyond the range of observation, in those regions rise and set. All of which goes to show not only that the earth is circular in shape, but also that it is a sphere of no great size. For otherwise the effect of a slight change of place would not be so quickly apparent. Consider then how Aristotle is reasoning, and I think we can reconstruct out of it a very simple argument that's implicit in what he's saying. First, let's consider a sort of illustration of the case. Imagine the Earth were flat, and here's the Earth, and here's perhaps you up here somewhere northerly, like Oswego, New York. Here's our friend who's a little bit below the equator, and here's a friend of ours who's near Antarctica. If the Earth is flat, they all ought to be able to see the same stars. Sure, they would be lower than the horizon for some. For this person here in a northern place, the North Pole star here, the North Star, would be higher in the horizon than it would be for this person. But still it would be visible. And furthermore, all these stars that our friend down near Antarctica could see would be visible to us. They'd be a little lower on the horizon. They'd be closer to the horizon, but they'd be visible to us. But that's not what we discover. So Aristotle reasons that the world is not flat, and in fact he reasons that it's a sphere. Let's take the first part of that reasoning. I've reconstructed an argument that I think is implicit in what he's saying. It seems to have two sentences and a third sentence which we could call the conclusion of the argument. If the Earth is flat, then we can see the same stars anywhere on Earth. It is not the case that we can see the same stars anywhere on Earth. Therefore, he concludes it is not the case that the Earth is flat. This is an argument. And Aristotle's making an argument that the Earth isn't flat, and he has other arguments that it's most likely a sphere. Now, what makes it an argument? It's interesting. We have several sentences. Some of them are trying to convince us of something. And then there's the thing they're trying to convince us of, isn't there? This we traditionally call the conclusion. And these other sentences in logic we traditionally call premises. In fact, you and I can just define an argument as an ordered list of sentences, one of which we call the conclusion, and all the others we call premises. That can be, from now on, our definition of argument. It's a very thin definition of argument. Some logicians wouldn't like it. They would think it was too thin. But you and I want to have a definition of argument that doesn't say what's good or bad. We want that to be an additional thing that we define later. So if we just define argument alone, not saying whether it's good or bad, that'll be sufficient for us. We can say an argument is just a list of sentences, an ordered list of sentences like this. Here they are, 1, 2, 3. And one of them we call the conclusion, and all the others we call premises. There's an old tradition in philosophy to write out your argument and draw a line and then put your conclusion below it. That's not really part of our logic. It's just an old tradition that's kind of handy to do. And that's what I've done here. You sort of see that line and you know everything above the line is a premise and in the sentence below is a conclusion. So I've tried to reconstruct what I think is the implicit argument in Aristotle. One of the implicit arguments, this one that the Earth isn't flat. It looks to me like a good argument. But that's our puzzle. What makes an argument a good argument? We've got this very simple definition of argument, an ordered list of sentences, one of which we call the conclusion, all the others of which we call premises. But there are good and bad arguments, aren't there? So what makes a good argument good? What makes a bad argument bad? That's a very interesting and important question. And we'll have to think about it very carefully. The answer that people often give when you ask, what makes an argument good? And you explain that you're thinking about an argument in terms of a relationship between these premises, where there may be many premises, but here we just have two, and the one conclusion. Generally, the answer you get from people is, well, it's good if the conclusion follows from the premises, or it's good if the premises show you the conclusion, right? Or it's good if the premises lead to the conclusion, or it's good if the premises make the conclusion seem very correct. These are all useful ways of thinking about it. Follow from, make it seem correct, indicate it, lead to it. But really, in the end, they're not very clearly defined, are they? They're just sort of giving us a vague sense of, we want it to be the case that somehow this stuff leads to that. That's why in logic we need something much more rigorous than that. And I think the important thing, if you think about it, is really going to be about truth and falsity, because remember, at least in our propositional logic, that's the main semantic principle we have, is every sentence is either true or false. So what about in terms of truth and falsity? Well, it would seem that these premises are trying to tell me, they're trying to convince me that that's true, aren't they? But I'm really going to in the context of this argument, my sense that this is true, supposedly, if the argument's a good argument, is somehow dependent upon or revealed by or shown by these other sentences being here, right? And presumably they are true. Aristotle believes this. He believes this, right? And then he's saying, you ought to believe this. So it's a relationship between the truth value of the sentences. And if I think my premises are true, what am I really saying? I'm saying that my conclusion is true. So that's our hint, right? A good argument is an argument where somehow if the premises are true, the conclusion is true. But that's a little too weak. If you think about it for a minute, sometimes two sentences are both true, but they have no relationship to each other. They have no relationship to each other, right? It's true that I'm talking to you on a Tuesday right now, and it's also true that it's sunny. But these are sort of two independent facts, you know. So it's going to be rainy some Tuesdays, and it's going to be sunny some Wednesdays. It's, you know, their truth value is, they both happen to be true right now, but there's no obvious relationship between their truth value. There's no link that relates them in some necessary way. So we need to say something more than just, if these were true, then that's true. We need to say that that's got to be a necessary relationship. It's got to be a very strong relationship, essential. And so what we can say is, an argument is good if necessarily, if the premises are true, then the conclusion is true. That is the most important thing we'll say during this entire course. We've introduced two new concepts: the idea of an argument and the idea of a good argument. So let's review them. Our definition of argument is very simple, right? It's just an ordered list of sentences, one of which we call the conclusion, and all the others we call premises. But we also said, okay, there's good and bad arguments. How are we going to define a good argument? And we introduced that idea by saying it's an argument for which necessarily, if the premises are true, then the conclusion is true. We have a name for that. Since it's a technical term, it's handy to have a special name for that. We call it a valid argument. So this is the most important sentence of our lectures. We're going to use it to guide everything we do from now on when we're building our logical language, because we want our logical language to be able to develop, help us find, help us analyze valid arguments. So memorize it. A valid argument is an argument for which necessarily, if the premises are true, then the conclusion is true. Note two things about this. One is, we know what most of the parts mean. You and I know what if-then means. We've defined that. Premises and conclusion, those are terms we use, names for kinds of sentences, you know, in our argument. The only thing that's unclear here is this necessarily. So I need to figure out what that is. I need to analyze that and be able to say in a precise way what necessarily means. The other thing I would say is, this is the ground floor for us. This is the most important sentence, as I said, of our lectures, because this is how we try to build our logical language and our reasoning system from now on, is to respect this principle. Sometimes you'll look in a dictionary and you look at the word valid and they say, a valid argument is an argument that follows the rules of logic. That's a terrible definition, because in fact, we build the rules of logic by trying to make sure that they will produce valid arguments. So this is actually our guiding principle. This is our guiding principle. A valid argument is an argument for which necessarily, if the premises are true, then the conclusion is true. By the way, notice that this doesn't tell us whether the conclusion is true. It tells us that necessarily, if the premises are true, then the conclusion is true. But if my premises are false, maybe my conclusion is false. We'll have to investigate that. But right now, it's clear from the definition that it's only saying if the premises are true, then the conclusion is true. So it can be useful to say, well, I want to know about the really good arguments, ones that are not only valid, but I put true premises in. And those we traditionally call sound. So the definition of a sound argument is a valid argument with true premises. Three ideas or three concepts, and we really do want to make sure we understand all three and we've memorized all three ideas. What is an argument, what is a valid argument, and what is a sound argument? We're going to spend a lot of time thinking about this idea of a valid argument. Right now, what we need to do is say, how would you check on that? How would you analyze an argument to determine whether it's valid? And it's going to turn out that we have two ways to do that. Let's talk about one of them now.